Welcome to our new series of mathematics, and here we shall discuss engineering mathematics and the mathematical physics topics, and it will be also helpful for higher mathematics course. So at first we shall start from the topic that is known as the matrix, or you can say matrices. So this is our first topic, matrix. And for higher mathematics, the topic of matrix that is very important and from which we can discuss, that is known as the rank of matrix. Okay, so there are many things to discuss about the introductory course of matrices and matrix, because there are different types of matrix, like square matrix, unitary matrix. Okay, so different types of matrices are there, but here we are starting our discussion from the rank of matrix, and then we will discuss the eigenvalues and eigenvectors that are very important for higher mathematics course. And at the end, if there is enough time, then we'll discuss the another topic, that is the different types of matrix. Okay, so at first discuss the rank of matrix. Okay, so suppose there is a matrix. If there is any matrix, that is A is any matrix, and it is the matrix of type, suppose M cross N. Okay, so what do you mean by M cross N? Those who are actually know the matrix very well and have the preliminary idea of matrix and matrices, they know that. And from your 11th class and 12th class topic of matrix, you also know that M is the number of rows denoting and N is the number of columns. So now there is a concept that is the known as the submatrix of A. Submatrix of A. So what do you mean by submatrix of A? So here we are considering A is any matrix of type M cross N, and what do you mean by the submatrix of A? So look at this. If there is a matrix A and the submatrix is actually obtained by leaving some rows and columns from A. So what is the submatrix of A? So submatrix is a matrix that is obtained by leaving some rows and columns from the matrix A. Okay, so this is the submatrix of A, and at the end of the lecture we will see that how to calculate those rank of matrix for examination purpose. But we have to also deal with the theory behind those concepts, because it is necessary to understand the basic theory of those properties of the matrices and matrix. So now this is the submatrix. You can call that the matrix obtained by leaving some rows and columns from capital A. This matrix is called the submatrix of A. And in particular, any matrix, suppose there is a matrix capital A, any matrix itself is a submatrix of A, because it is obtained by leaving no rows and no columns. Okay, so it is little bit tricky that you can say that any matrix, this is very important, any matrix is a submatrix of itself, because it can be obtained by leaving no rows and no columns. Okay, it is little bit tricky statement from the matrix itself, but it is important from the matrix itself, because if you have any MCQ type question that or is it the true or false type question, that there is a statement that any matrix is submatrix of the matrix itself, so you have to state whether the statement is true or false, then it is obviously a true statement. Okay. Okay, now we are discussing the minors. What do you mean by minors? Okay, so minors of a matrix. Okay, we know that every square matrix possesses a determinant. Okay, if you have this matrix or this is a square matrix, then it possesses a determinant. Like 4 cross 4 matrix, it possesses a determinant, or 5 cross 5 matrix, it also possesses a determinant. Okay, so suppose let if A be a m cross n matrix, okay, then the determinant of every square submatrix, just note it down those theories and you will understand better by some examples. So we know that every square matrix possesses a determinant, and if A is B and m cross n matrix, then the determinant of every square submatrix of A is called the minors of the matrix. Is called minors of the matrix. A. So this is very important statement. So if A be a m cross n matrix, then the determinant of every square submatrix. So how to obtain the submatrix, that we have already discussed, that if we remove some rows and columns from a matrix, then we can obtain the submatrix, and the submatrix, if there is a square matrix, so the submatrix is also be a square matrix, and for the determinant of every square submatrix is called the minor of the matrix A, that is the m cross n matrix. Okay, so let us discuss this theorem or this concept with some example. So our example, let us take suppose there is a matrix A, I am taking, so this is 2 4 1 9 1, then 0 5 2 5 2, then 1 9 7 3 4, and then 3 minus 2 8 1 8. Okay, we have this matrix, this lengthy types of matrix, and here we have to tell this what is the order of the matrix, or you can say what is the number of rows and columns of the matrix. So here there are 4 rows, 1 2 3 4, and 5 columns. So this is a 4 cross 5 matrix. Okay, so this is the m cross n. Okay, now suppose if we leave any 2 columns from A. Okay, so if we leave any 2 columns from A, so just do that. So if we leave any 2 columns from A, so now we shall get a square submatrix of A, so of order 4. So if we leave, just look at this, if we leave any 2 columns, because to obtain the submatrix we have to leave columns and rows. Okay, so at first we are leaving any two columns from this original matrix A, then we shall get a submatrix of a submatrix of A. Okay, so now look at this. So what will be the submatrix? Then the submatrix will be like this: 2 4 1 9. Okay, 2 4 1 9. Okay, don't leave any two columns, sorry, any columns. We shall get the submatrix of A. So just leave this column and we get 2 4 1 9 0 5 2 5 1 9 7 3 and 3 minus 2 8 1. So this is a square submatrix. This is a square submatrix of order 4. So now we get a square submatrix of order 4, and you can also get like this. If we wish to remove this column, you can remove this column also, or any columns from this matrix. You will get some 4 cross 4 order of 4 square matrix, that is 4 rowed minors. So this is known as the 4 rowed minors, that is this has 4 rowed. Okay, so if now we leave 2 columns and 1 row from A, then we shall get a square submatrix of A of order 3. So now just leave 2 columns and 1 row. So now you can leave these 2 columns and also leave 1 row. Then what we suppose we leave these 2 columns and this 1 row, we are leaving these columns. So we get 2 4 1 0 5 2 1 9 7. So let it down: 2 4 1 0 5 2 and 1 9 7. So this is a order 3 square submatrix. So this is also a minor. Now similarly you can get 4 1 9 5 2 5 and 9 7 3. This is also a square submatrix. Okay, 4 1 9 5 2 5 and 9 7 3. So these are the submatrices of order 3. These are also known as 3 row minors. So previously we got 4 rowed minors, here 4 rowed minors, and now we got 3 rowed minors. Similarly, if we leave 3 columns and 2 rows from A, then we shall get a square submatrix A of order 2. So now just leave 3 columns here. So now I am removing these 3 columns and 2 rows also. So 2 rows also. Okay, 2 rows also. Then we have 2 4 0 5 like this, 2 4 0 5, or you can get 4 1 5 2 also, 4 1 5 2 also. This is the 4 1 5 2. This is the 4 1 5 2. So here we shall also leaving 3 columns. Okay, so sorry, not from this, here this is the original matrix, very sorry, this is the original matrix, and you have to leave 2 columns and 2 rows, 2 columns 1 rows, or 3 columns 2 rows. Okay, so if we leave 3 columns and 2 rows, then we shall get this type of 2 rowed minors. This is also known as 2 rowed minors, or you can say this is a square submatrix of order 2. Okay, so now these are the 2 root minus of A. Okay. And similarly for 1 root minus, we can directly say that this 2419, this single number 2 comma 4 comma 1 comma 9, 0 comma 5, these all are 1 root minors of A. This concept is very similar. So from the first, if we summarize this concept, that is, if there is a matrix A, this is a square matrix, you can obtain the submatrix by removing some rows and some columns. And if any matrix, if we choose like this here, this is the 4 cross 5 matrix, then if we leave one columns, okay, and then we have 4 row minors, or you can say the square submatrix of order 4, then we can leave remove the 2 columns and 1 rows. Okay, so similarly we can remove 3 columns, 2 rows, and the single numbers are 1 row minors of A. So this is the concept of minors. Okay, now there is a theorem that is known as the rank of matrix. Okay, so what is the definition for this? So the definition is a number R is said to be a rank of a matrix capital A if it possesses the following properties. Okay, so number 1 properties, there at least one square submatrix of order R whose determinant is not equal to 0. So this is our first point. So we can say any number R is said to be the rank of a matrix, original matrix. So if there are at least one square submatrix of order R, there may be many, but at least one square submatrix of order R, because we are choosing this number R, so there is a at least one square submatrix of order R whose determinant, if we compute the determinant, then determinant should not be equal to 0. So this is the first property for determining the rank of the matrix. So this is the first condition, and the second condition, that is, if this is not a type of condition, theorems, this is actually theorems, or you can say the definition, if the matrix capital A contains any square submatrix of order R plus 1, then the determinant of every uh, then the determinant of every square submatrix of order r plus 1 should be 0, because here just look at this, because the rank in the definition we have already said that a number r is said to be rank of a matrix capital A. So now we are defining that the r is the rank of that matrix. So now if r is the rank of the matrix, the first condition is that there are at least one square submatrix, that is actually the minors, there are at least one square submatrix of order r whose determinant is not equal to 0. And how to compute these square submatrix? By removing rows and columns. We have already seen that, and in our upcoming lectures we shall compute many problems by this type of process. And this is the main concept behind this, that there are at least one square submatrix of order r whose determinant is not equal to 0. Then we can say that r is the rank of that matrix. And the next point is, if the matrix A contains any square submatrix of order r plus 1, that is the order greater than the rank. Okay, so because this is the rank r, matrix has the rank r, so order r plus 1 means it is greater than the rank of that matrix. Then the determinant of every square submatrix of order r plus 1, that is the order greater than the actual rank of that matrix, should be 0. Okay, so suppose there is a rank of any matrix, that is 3, then you have to have a at least one square submatrix of order 3, and the other square submatrix of order 4, 5, 6, if it possesses, then it should be 0. Okay, this is the second properties. Okay, so we can define, in short we can say, the rank of a matrix is the order of any highest non-vanishing minor of the matrix. Okay, so here the rank of the matrix is the order of any highest non-vanishing minor of the matrix. So this is obviously true, that is highest non-vanishing minor means you can get at least one of those types of square matrix, or you can know the square sub matrix. So this will be the rank of that matrix itself. So, and we shall define the rank by this symbol. That is the rank of the matrix. Okay, and there is an important property, that is the rank R of an m cross n matrix can at most be equal to the smaller number m and n, but it may be less. So the rank R of an m cross n matrix can at most be equal to the smaller number m and n. So is equal to the smaller of the numbers m and n, but it may be less. Okay. And if there is a matrix capital A which has at least one non-zero minor of order n, and there is no minor of A of order n plus 1, then the rank of the matrix A is n. So it is very obvious that if, so this is my property, if there is a matrix capital A which has at least one non-zero, so this is very important, that is non-zero determinant, one non-zero minor of order n, and there is no minor of A of order n plus 1, then the rank of the matrix is n. And thus the rank of every non-singular matrix of order n is n. So you can obviously say, because what is non-singular matrix, that is determinant not equals to 0, and so you can say thus the rank of any non-singular matrix of order n has the rank n, obviously. Okay, so suppose there is a square matrix, so we have a square matrix, that is capital A. Okay, now the rank of the square matrix, this capital A of order n, can be less than n if and only if A is singular. So this is very important property. Suppose there is a square matrix, that is capital A. So the rank of a square matrix capital A of order n can be less than n if and only if A is singular. That is determinant of A equals to 0. And obviously the rank of every non-zero matrix is greater than equals to 1, and so this is the note point. Since the rank of every non-zero matrix, so this is known as a non-zero matrix, means that is not a null matrix. Suppose we know that this is a null matrix also, so not this type of matrix. So you have this type of matrix or you have this type of matrix, these are non-zero matrices. Okay, with one element, two element, or two rows, three rows, three columns, anything happen. So If there is a non-zero matrix, then obviously the rank of this non-zero matrix is greater than equals to 1. And we can agree, we can assign the rank to null matrix as 0. This is obvious. Okay. So these are very important properties, and this is actually the definition of the rank of the matrix, and these are the very important properties of the about the rank of the matrices. And now we are going to discuss two important results that will be very helpful for problem solving approach. These are very important results. Maybe I am not discussing the proof of these results, but these are very important results. The one number result is the rank of matrix is less or equals to R if all R plus 1 root minors, that is the minors of R plus 1 order, okay, minors of the matrix vanish. So obviously that the rank of matrix is less or equals to R, that is equal to the R or less than R, if all the higher orders, that is R plus 1 root minors of the matrix vanish. Obviously, because you have to have one non-zero square submatrix of order R. Okay. So then R is obviously the rank of that matrix. And if the second point, if rank of matrix is greater than equals to R if there at least one R root minor of the matrix. If there is at least one R root minor of the matrix which is not equal to 0. Obviously, if the rank of matrix is greater than equals to R, then if there is at least one R root minor of the matrix which is not equal to 0. So let us discuss one example, and these two results are very important. Okay. So the first result is the rank of matrix is less or equals to R if all R plus 1 root minors of the matrix vanish, and if the rank of matrix is greater than equals to R, then if there at least one R root minor of the matrix which is not equal to 0. Okay, otherwise it will be less or equals to R. So suppose we take an example. So just take an example. Let A, taking some simple example, that is 1 0 0 0 1 0 and 0 0 1. So this is very popular matrix, and you know that this is a unit matrix. What type of matrix is this? This is a unit matrix and of order 3. Okay. So now if we compute the determinant, so then you can find that this determinant of this A is obviously, this is, what is the determinant? This is equals to 1 because it is a unit matrix. Okay. Okay. So therefore A is a non-singular matrix. Okay. So A is a non-singular matrix. Okay. So we know that from the theorem that if there is a matrix A, and it has some order n, and if this matrix is itself non-singular, that is determinant of A is not equals to 0, then obviously we can say that the rank is n. Okay, then the rank is simply n, because if we have some A matrix and of order n, and the matrix the determinant of the original matrix is itself non-singular, then obviously we can say that this is the order, that is n is the order. Hence, what is the rank of that matrix? Okay, what is the rank of the matrix? So hence rank equals to 3 for that matrix. Okay, and there is actually this property is known as the rank of unit matrix. The rank of unit matrix of order n is n. So this is a completely whole result, and you can just remember this result. Okay, the rank of unit matrix of order n is n. Okay, so this is a very good important result. Okay, now we know that if there is a null matrix, suppose let A equals to 0 0 0 0 0 0 0 0 0, then what is the order? What is the rank? So you can assign this rank as simply 0. Okay, rank of the matrix is simply 0. Similarly, let us take another example. Suppose we have the matrix A equals to 1 2 3 and 2 3 4 and 0 2 2. So at first you can check that whether it is a singular matrix or non-singular matrix. Okay, so now first check this, whether it is a singular or non-singular matrix, and it is a 3 by 3 matrix, 3 cross 3. So first check this. So let us take the determinant of the matrix 1 2 3 2 3 4 and 0 2 2. Now check the determinant. So determinant of A, what will be the determinant? Okay, then 1. So you have to take this element and just of these rows and columns, of these rows and columns, then 3 4 2 2. So 3 and 2 6 minus 8. So 1 into 6 minus 8. Okay, minus 2 into 4, minus 2 into 4 minus 6, minus 2 into 4 minus 6. Okay, is it correct? Yes. Minus 2 into 4, yes, minus 2 into 4 6, and that will be equals to 2, and that is not equals to 0. So again this is very good luck, that is again we have not determinant, this determinant is not equals to 0, so this is also a non-singular matrix. So this is also a non-singular matrix. So order is, here rank is 3, because it is a non-singular matrix of order 3, so the rank is 3, because if you have a matrix A and of order n, and if it is it has the determinant, that is the determinant of A is not equals to 0, then the rank is n, that is the order of that matrix. So we have learned so much these topics of that is the rank, what is the rank of the matrix, what is the minors and sub matrix of the matrix. And in our next lecture we shall discuss various types of problems depending upon these concepts of rank and sub matrix and minors. And please like our channel and motivate us to create more types of videos on higher mathematics and also some another topics of science. And like our channel and subscribe to us. Thank you very much.